Welcome to Astronomy Daily, your go-to podcast for the latest and greatest news from across the cosmos. I'm Anna.
And I'm Avery. We're so glad you could join us today for another exciting dive into the universe's most captivating stories.
We've got a jam-packed episode for you today, full of fascinating developments. We'll be starting close to home, discussing the recent SpaceX Crew 11 launch scrub and why those pesky cumulus clouds caused a delay.
Then we're going to venture much further out into the galaxy as we uncover some incredible new findings from the James Webb Space Telescope, which has exposed dormant black holes in the act of devouring stars. It's truly like nothing we've ever seen.
And speaking of things we've never seen, we'll be tackling the thrilling idea of chasing down an interstellar visitor, the newly discovered comet 3I/ATLS. Could we actually send a mission to intercept it? We'll break down the feasibility.
Finally, we're taking a leap into the realm of science fiction turned potential reality. Warp drives. We'll explore the cutting-edge research that suggests faster-than-light travel might just be possible within the next century. It's a mind-bending topic that could redefine space exploration. So let's get started.
All right, let's kick things off with some news from our very own planet, specifically Cape Canaveral, Florida. SpaceX unfortunately had to scrub the recent launch attempt of their Crew 11 astronaut mission for NASA.
That's right. This happened on July 31st, just over a minute before liftoff. The culprit? A bank of cumulus clouds that appeared right over NASA's Kennedy Space Center.
It sounds like the weather just didn't want to cooperate with the excitement of the Crew 11 launch. NASA commentator Daryl Mail explained during the coverage that they could literally see the clouds moving over the pad.
And it's not just about visibility, it's a critical safety issue. Nail elaborated that there's a 10-mile radius standoff area around the launch pad for these dark cumulus clouds. You absolutely do not want to send the rocket through a tall cloud like that, as it could generate energy from the rocket passing through it, which is obviously a significant risk.
Absolutely. Safety always comes first, especially when human lives are on the line. But there's good news. SpaceX will be trying again. The next attempt is scheduled for Friday, August 1st at 11:43 a.m. Eastern Daylight Time, with another chance on Saturday, August 2nd at 11:21 a.m. EDT.
When it does launch, the Crew 11 mission will see a SpaceX Falcon 9 rocket lift off from Launch Complex 39A at KSC. It's carrying the Crew Dragon Endeavour spacecraft, which is making its sixth flight, setting a new reuse record for Crew Dragon vehicles.
The four-person crew is an international one, featuring NASA astronauts Zena Cardman and Mike Finke, Kamiya Yui from the Japan Aerospace Exploration Agency, or JAXA, and Oleg Platonov of Russia's space agency, Roscosmos.
Once launched, the Crew 11 will embark on an approximate 40-hour journey to catch up to the International Space Station, which orbits at a remarkable speed of about 17,500 miles per hour, or 28,000 kilometers per hour, roughly 248 miles or 400 kilometers above Earth's surface. This will be SpaceX's 11th operational astronaut mission for NASA through its Commercial Crew program, highlighting the growing role of private spacecraft in space travel.
From launch delays, we now pivot to some truly mind-bending discoveries courtesy of the James Webb Space Telescope. Prepare yourselves for a cosmic horror story because the JWST has caught dormant black holes in the act of devouring stars.
Nothing like we've ever seen is how lead author Megan Masterson from MIT describes these findings. Unlike the active galaxies we usually hear about, where black holes are constantly gorging on nearby matter, these are dormant black holes. They mostly slumber, stirring only for a brief, spectacular feast on an unlucky passing star.
This new study, published in Astrophysical Journal Letters, details how astronomers from MIT, Columbia, and other institutions, used JWST to peer through thick layers of dust in nearby galaxies. They were looking for the aftermath of what are called tidal disruption events, or TDEs.
These are incredibly rare cosmic occurrences. Imagine a galaxy's central black hole pulling in a nearby star, tearing it apart with immense tidal forces, and then releasing a massive burst of energy. Since the 1990s, only about 100 TDEs have been documented, mostly in galaxies with little dust, making the X-ray or optical light easier to observe.
But the brilliance of JWST as the world's most powerful infrared detector is that it can see through that obscuring dust. Previous work by the MIT team showed that while a TDE's X-ray and optical light might be hidden, that same burst of light heats up the surrounding dust, generating a new signal in the form of infrared light.
Exactly. And with JWST, they've now studied signals from 4 dusty galaxies where they suspected TDEs occurred. Inside the dust, JWST detected clear fingerprints of black hole accretion. That's the process where material like stellar debris spirals and eventually falls into a black hole.
What's fascinating is that the patterns detected by JWST were strikingly different from the dust around active galaxies, where the central black hole is always pulling in material. This confirmed that a tidal disruption event did indeed occur in each of the 4 galaxies, and critically, they were products of dormant black holes, which had little to no activity until a star wandered too close.
This really highlights JWST's incredible potential to study these otherwise hidden events in detail. It's helping scientists understand the key differences in environments around active versus dormant black holes. Megan Masterson emphasized that they've learned these events are powered by black hole accretion, but they don't look like environments around normal active black holes.
To get a bona fide signal, as Masterson put it, they specifically looked for a peak in infrared light that could only be produced by black hole accretion. This process is so intense that it can blast electrons out of atoms, like neon, which then release infrared radiation at a very specific wavelength that JWST can detect.
There's nothing else in the universe that can excite this gas to these energies, except for black hole accretion, Masterson explained. This was their smoking gun. They then used JWST to detect another infrared wavelength indicating silicates or dust, mapping its patterns to differentiate between a temporary TDE and a constantly active black hole.
The results definitively showed patterns unlike typical active galaxies, confirming these were dormant black holes that only flared up due to a star being disrupted. This research is just the beginning. The team plans to uncover many more hidden TDEs, which can then serve as powerful probes to understand fundamental black hole properties, like their mass and spin, and how long they take to consume stellar material. That's truly wild. Speaking of rare cosmic occurrences, we've had a few close encounters of our own here in the solar system recently.
You're talking about interstellar objects, aren't you? It's a tantalizing prospect. The idea of visitors from beyond our sun's reach.
Exactly. Since 2017, we've spotted 3: 1I Oumuamua, 2I Borisov, and just this month, 3I Atlas. This latest one, discovered by the Asteroid Terrestrial Impact Last Alert Survey, is zipping through the inner solar system in the latter half of 2025.
And of course, the immediate question is always, can we get a closer look? All assets on the ground and in space will be turned towards 3I Atlas. But what would it look like up close? Can we even consider chasing down such a speedy visitor?
Well, a recent study from Michigan State University, published on the Archive preprint server, actually explored the feasibility of just that. It's titled The Feasibility of a Spacecraft Flyby with the Third Interstellar Object 3I Atlas from Earth or Mars. The study could serve as a template for future missions to these enigmatic objects.
Lead author Atsuhiro Yaginuma told Universe Today that a close flyby would enable measurements impossible from Earth. We could get direct compositional and isotopic analysis of ices, dust, and organics in situ, plus high-resolution imaging of its nucleus, revealing its shape, size, spin state, and active jets. All of this would offer critical insights into planetary formation and evolution in an alien system.
We already know a bit about 3I Atlas. It's a very old object, hailing from the thick galactic disk of the Milky Way. Gemini North gave us a close-up view mid-month, confirming its cometary in nature. It's currently shining at plus 17th magnitude, but is expected to brighten 100-fold to plus 12th magnitude as it reaches perihelion about 1.356 astronomical units from the Sun on October 29.
Unlike Oumuamua, we're seeing 3I Atlas on its inbound leg, which is a big advantage for planning an intercept. However, it's really moving at a speedy 58 kilometers per second relative to the Sun. Catching up would be a whirlwind mission. The study looked at various scenarios, with an Earth or Mars departure between January 2025 and March 2026.
An Earth departure would demand a high initial delta V, around 24 kilometers per second, which is a huge amount of thrust, although the Dawn spacecraft almost matched this in its post-launch phase. Interestingly, a Mars departure would need much less, only about 5 kilometers per second in early 2025. This is because 3I Atlas makes a much closer pass by Mars at 0.2 AU on October 3rd, compared to its closest Earth passage at 1.8 AU on December 19th.
Yaginuma pointed out that Mars orbiters could image 3I Atlas when it's not observable from Earth, especially around its perihelion. This would be crucial for understanding its activity. Repurposing existing Mars orbiters like Maven or Odyssey might even be possible if they have enough fuel.
The study also considered missions already built, but looking for a new destination, like the Janus Duo, two small, simplex spacecraft that were shelved after delays forced the Psyche mission to take an alternate path. Being relatively light, they might be candidates if we could launch them sooner rather than later. NASA's OSIRIS-APEX, a repurposed OSIRIS-REx, is also set to perform an Earth gravity assist in September 2025 and could make long-range observations of 3I Atlas starting in November.
Despite these possibilities, intercepting something moving at over 60 kilometers per second would make imaging during such a fast encounter incredibly tricky. For comparison, New Horizons passed Pluto Charon at only 14 kilometers per second.
The future, however, looks promising for high-speed flybys. The European Space Agency's proposed Comet interceptor, planned for launch in 2029, will be parked at the Sun-Earth L2 point, awaiting a target. While designed for new comets, it could potentially chase down an interstellar object if it happens to pass by.
The key takeaway from the study is clear. The earlier we can spot incoming interstellar objects, the more options we'll have, and the less energy will be required to go after them. A new generation of all-sky surveys, like the recently commissioned Vera C. Rubin Observatory, promises to do just that, spotting these cosmic interlopers early and helping us study them like never before.
From chasing interstellar comets, we now turn to a concept that has truly captured the human imagination for decades: warp drive. We're talking about the ability to travel faster than the speed of light, a concept that started in the realms of Star Trek and Star Wars, but is now being seriously investigated by scientists.
That's right, Anna. Scientists are actively researching whether bending space-time itself could allow us to reach distant stars quickly, turning what was once pure science fiction into a potential scientific reality.
The fundamental idea of warp drive doesn't involve rockets burning fuel. Instead, it involves bending space-time. Physicist Miguel Alcubierre first described this concept in 1994. He proposed creating a bubble around a spacecraft that compresses space in front of it and expands space behind it.
And the clever part is inside this bubble, your ship doesn't actually move faster than light. It stays still while space-time itself shifts around it. This ingenious loophole allows the bubble to exceed light speed without breaking Einstein's universal speed limit, which states that nothing with mass can travel at or faster than light speed within spacetime.
However, there's a massive catch. Creating this bubble requires something called negative energy or negative mass, which are strange materials that push space outward rather than pulling it in. Alcubierre's original theory suggested you'd need negative energy equivalent to Jupiter's mass, which is far beyond anything we can currently achieve.
But some researchers are working on this. NASA physicist Dr. Harold Sonny White, for example, believes that by tweaking the bubble's shape, this mass requirement could be reduced to about 700 kilograms, making the idea slightly more feasible. White even leads a NASA team developing the White-Juday Warp Field Interferometer, a device intended to detect tiny warp bubbles. While it's nowhere near enabling actual space travel, it's a crucial step.
And we have some hints of negative energy. Small amounts have appeared in experiments like the Casimir effect, where two metal plates placed close together create negative energy. But these tiny quantities are still a far cry from what's needed for warp drives.
Scientists are still debating the practicality of warp drives. Calculations suggest quantum fields at the warp bubble's edges might become infinitely large and unstable. Other simulations indicate exotic matter might escape the bubble faster than light, quickly destroying it. Even the smallest viable warp bubble, roughly 30 feet wide, would demand negative energy surpassing all positive energy in our universe. It's a truly immense challenge.
Professor Tim Dietrich from Potsdam University also highlighted another serious issue: causality paradoxes. He explained that using a warp drive might cause paradoxes once it crosses light speed, potentially disrupting our understanding of cause and effect. It's like traveling into the past.
Yet despite these significant hurdles, warp drives haven't been dismissed entirely. Professor Geraint Lewis of the University of Sydney believes we might discover exotic matter within the next century. He optimistically stated that Einstein's theory is 100 years old, but we've only scratched the surface, suggesting hyperfast travel might become achievable in the next 100 or 1,000 years.
Dr. White from NASA supports the idea that initial warp journeys could combine warp drives with traditional propulsion. Ships could leave Earth with standard rockets, engage warp drives once safely away, and deactivate them close to their destination. A trip to Alpha Centauri, which currently takes centuries, could then potentially take just months.
And interestingly, even if humans can't build warp drives, detecting aliens using this technology might be possible. Dr. Katie Clow, a cosmologist at Queen Mary University of London, suggests that collapsing warp bubbles would emit gravitational waves. If these exist, Earth-based detectors could potentially spot them.
Dietrich and Clough have studied scenarios where the exotic matter's containment field collapses, creating ripples propagating outward. Detecting these gravitational waves would be confirmation that someone else has already mastered warp drive. Dr. Clough even praised Star Trek Beyond for its more accurate depiction, noting that the bullet shot was loosely based on how light curves around a warp bubble.
The visual depiction of warp travel in movies like Star Wars, with dazzling bursts of streaking stars, is also likely incorrect. According to Dr. Clough, looking forward would show objects shifted toward blue, while backward views would turn red due to warped-like wavelengths. Shapes would appear distorted, similar to viewing through curved glass. Research by physics students at the University of Leicester suggests passengers would instead witness a glowing disk due to cosmic background radiation shifting into visible light.
Dr. Clough even praised Star Trek Beyond for its more accurate depiction, noting that the bullet shot was loosely based on how light curves around a warp bubble.
Warp drive remains speculative and distant, but history teaches us not to dismiss such concepts lightly. Touchscreens, voice assistants, and 3D printing all began as improbable ideas from fiction. Star Trek famously predicted warp travel by 2063. While ambitious, scientists agree that breakthroughs could bring us closer faster than we imagine.
Continued exploration in physics, quantum mechanics, and engineering could one day make warp drives a reality. Whether humanity ever travels at warp speed remains uncertain, but the pursuit itself enriches our understanding of the universe, pushing scientific boundaries. Perhaps someday, space journeys lasting mere moments instead of lifetimes might transition from science fiction into our everyday reality. Well, that brings us to the end of another fascinating episode of Astronomy Daily. What a ride it's been today.
Absolutely, Anna. It's always inspiring to see how far our understanding of the universe has come and how much more there is to explore.
Indeed. Thank you so much for tuning in to Astronomy Daily. We hope you enjoyed exploring the cosmos with us today.
You can find more episodes of Astronomy Daily and stay updated on the latest space and astronomy news by simply visiting our website at astronomydaily.io.
We'll be back tomorrow with more stories from across the universe. Until then, keep looking up.